we're going to be calculating the surface area of pyramids. All right, so here's an example of a pyramid. Remember, it has one base. It has that vertex point at the top. Instead of having two bases, it has a vertex point. And remember, we do have something called slant height when it comes to pyramids and cones, and it's denoted by the cursive L. All right, so my formula is 1/2 of the perimeter of the base times slant height plus the area of just one base this time, because we only have one base. Okay, so 1/2 perimeter of the base times slant height plus the area of my base. Let's try a couple examples. So I know surface area is equal to 1/2 perimeter times slant height plus the area of my base. So let's figure out what we know. So we have 1/2 the perimeter of my base. My base is a square. Okay, so we have a base of a square there. So 8 times 4, that's going to be 32. My slant height is given to us. That's 10. Oops, sorry, that should be a times 10. Find my eraser here. Times 10 plus the area of my base. We said already the area of the base there is a square, so that's plus 8 times 8. Okay, so let's clean it up a little bit and simplify. So half of 32 is 16. 16 times 10 is 160. Plus 8 times 8 is 64. So my surface area is 224 surface area. So we're going to talk square inches. Let's try one more. Okay, so this one here, we have a hexagonal prism, our pyramid, hexagonal pyramid. So we're going to be using our special right triangle skills here. Let's talk about what we know. So we have surface area equals 1/2 perimeter of the base times the slant height plus the area of one base. So 1/2 perimeter of the base. Okay, so I just need to add up I have 6 sides of 10 each, so that's 60. 60 times my slant height, which is given to us, which is 22. Now the area of my base, we got to think about this. This is that regular hexagon. See if I can draw a nice one here. And if you remember, the regular hexagon is divided into equilateral triangles. So we know the base of the equilateral triangle, all sides, is going to be 10. But I need to think about the area of this is 1/2 times NAS. Number of sides, the apothem, and the side length. So I have 1/2, I know. The number of sides is 6. We got to find that apothem. That apothem, remember, is this piece right here. So because it's equilateral, we have a 30, 60, 90 triangle. I know the short leg has to be 5. So that makes the height of that triangle 5 radical 3. So my apothem is going to be 5 radical 3. All right, so let's plug in what we know here. The area of my base, 1/2. Number of sides, 6. My apothem we just figured out was 5 radical 3. My side length is 10. Okay, so on this type of problem, this is where it really starts to come together. We found the area of a hexagon. We had to know our special right triangles, and we had to know our surface area formula. So let's clean it up. We have 1/2 of 60, that's 30 times 22. That gives me 660. Okay, and then let's see, we have 1/2 of 6 is 3. 3 times 5 is 15. 15 times 5 is 150 radical 3. Okay, that is an acceptable answer. We could also, my goodness, I'm having a horrible time writing here. We can also go ahead and type that into our calculator. So 660 plus 150 radical 3 gives us, oops, I mistyped. Gives us 919.8 square units.